Hello, this video is on Intro to Factored Form for Quadratic Equations. There are two learning targets that go with this video. The first one is I can write quadratic equations in factored form. And the second one is I can graph equations given in factored form. Okay, so this is just a quick summary slide of the three forms of quadratic functions we will know by the end of this video. Top one is standard form, ax squared plus bx plus c. This is the one we learned first. We know that the c value is our y-intercept, and to find the axis of symmetry from standard form, we have to use the opposite of b over 2a. Okay, if we move on to the second one, y equals a x minus h squared plus k. That is vertex form. It was the second form of quadratics that we learned. This one is useful because it tells us the vertex, which would be the h and the k. Our last form, which is the new one, is called factored form. It looks like y is equal to a, parentheses x minus r1, and x minus r2. So factored form is useful because it gives us the roots. So it's important to clarify here, we have a couple different names for the same thing. So roots are the same things as the zeros or the x-intercepts. So for example, if we sketched a really tiny graph here, there we go. The point where the x-intercepts are right there and there, where they cross the x-axis, those are our roots. It's just another name for x-intercepts or zeros. So factored form tells us where our graph crosses the x-axis. Okay, so we are going to practice converting equations from standard form into factored form. We actually already know how to do this. If you think back to our unit on factoring in semester or quarter 2, we have to go back to diamond and box. So if you're given something in standard form, like here, ax squared plus bx plus c, we need to use diamond and box to get it into factored form. So if you remember in the diamond, we do a times c, so that would be 21x squared and then 10x. And then these two side spaces here, they have to multiply to give us 21x squared, but add to give us 10x. So that should be 7x and 3x. And then I'm going to transfer that into my box. So going back to my original equation, the x squared goes here, and 21 goes here, and 7x and 3x will now fill the last two spots. To get x squared, I would have to multiply x times x, and then x times 7 would give me 7x, and x times 3 would give me 3x. So then to rewrite this in factored form, it would be y is equal to x plus 3 and x plus 7. So if you remember our factored form equation on the previous slide, it's a x minus r1 and x minus r2. So like your root, or like your h value in vertex form, your roots lie. So here, my roots would be at -3, 0 and -7, 0. That's where my x-intercepts are. That's where I cross the x-axis if I were to see the graph of it. Looking at the second example, I would start this the same way. A times c would give me -30x squared here. B goes here, which is 7x. So it's going to multiply to give us -30x squared, but add to give us 7x. That would be 10x and -3x. Now my 2x squared goes here, and -15 here. Remember, those two always start in their same spot, the first term and the last term. The 10x and the 3x, -3x, fill our last two boxes. Now to get 2x squared, I'll have to do an x and a 2x. I'm going to put the 2x here because I can multiply it into 10x by multiplying by 5. And then x here because I can multiply by -3. So in factored form, this equation is y is equal to 2x minus 3 and x plus 5. Okay, so here, imagine these are helping me figure out the points where we cross the x-axis. So with the x-intercepts, if we go back to x-intercepts, we know y is always 0 there. So if I want to figure out what the roots actually are here, I would set x plus 5 is equal to 0, which tells me one of the roots is x is equal to negative 5. And now this is more helpful with a second binomial, this one. Setting it equal to 0 because y is 0 there, so then I need to add 3. And I get 2x is equal to 3, which tells me x is 3/2. So those are my two roots. If I wanted to write them as an ordered pair, I could. All right, now writing equations in factored form from a graph. We have the generic formula up top. I like to identify my roots first. So my roots are at -1, 0, and that's this one, and 3, 0, which is this one. So I can plug those in right away. So my equation would start as y is equal to a x minus -1, and then x minus 3, which would change this to adding. And it lies, so that makes sense. And now I just have to solve for my a value, and this is going to be similar to how we solve for the a value in vertex form. I have to plug another point in. So let's use the y-intercept, which is 0, -3, and I'm going to plug in 0 for x and -3 for y to help me figure out what a is. So I would get -3 is equal to a, 0 plus 1, and then 0 minus 3. And now I need to simplify, so I'm going to do the parentheses first. 0 plus 1 is 1, 0 minus 3 is -3. And now realize that these three are all multiplying together. So the -1 times 3 would give me -3, so I'm going to put it out front, times a. And I would divide by -3, and I get a is equal to 1. So my final form of my equation would be y is equal to 1, x plus 1, x minus 3. All right, let's look at another equation, or another graph, excuse me. Let's do our roots right away. Remember, roots are the same as the x-intercepts. This one is at -2, 0, that's this one. And the second one is here, that's at 3, 0. And let's plug those in for R1 and R2. So I get y is equal to a, x minus -2, and then x minus 3. That'll change to addition. Now I need to pick another value to get my a. So let's use this -1, 2 that's already labeled for us. So I would have 2 is equal to a, -1 plus 2, and -1 minus 3. Let's simplify our parentheses first. So I get 1 here and -4 here. I'm just going to simplify the one side. So 1 times -4 is -4, and that's multiplying by a. And then I would divide out -4. So simplified, a is equal to -1/2. I'm going to rewrite my final answer. Y is equal to a, which is -1/2, x plus 2, and x minus 3. Those are my roots, which I had already filled in. All right, so now we have two examples of how to graph when we're given an equation in factored form. I still like to start by identifying my roots. So remember that our generic equation is going to be a, x minus r1, and x minus r2. So in this case, my roots are going to be 4, 0. Remember, our roots lie, and then -2, 0.
See you later, Joe. We're leaving.
Then from there, I'm going to plot those 2 points first. So I'm going to plot one at 4, 0. And I'm going to plot one at -2, 0. Okay, so I have 2 points on my graph. Those are my x-intercepts. Obviously, I do not have a clear picture of my parabola yet, so I need to add more points to my graph. To do this, let's find our axis of symmetry. Our axis of symmetry will be halfway between our roots, so I'm going to find the average of them. So 4 plus -2 over 2, that gives me 2 over 2, which is 1. So that tells me my AOS is x equals 1. That's where my symmetry should be. So my vertex should fall somewhere along there. So my vertex, the x value should be 1, and I need to plug 1 in to figure out what the y is. So I get y is equal to, that's a little messy, let's back up here. I get 1 minus 4, 1 plus 2. So simplifying the parentheses, that would give me negative 3 times 3, which means y is equal to negative 9. So my vertex should be at 1, negative 9. Draw that point in there. Getting closer to my graph, so my vertex is at positive 1, negative 9. And I know where my x-intercepts are. So I'm going to make a table and plug some other x values in. I'm going to plug in 0 and negative 1 to get a clear picture. If I plug 0 in, I'll get y is equal to 0 minus 4 times 0 plus 2, which is negative 4 times 2, which is negative 8. I can reflect that over, and then I would plug in negative 1. When I did that, I got negative 5. Bear with me, it gets a little messy on the iPad. But I have my points, and then I would draw my curve through them. All right, let's look at one more example. I know there's a lot of steps involved in these different types, so let's just think about what we're given. So we're in factored form. We know our roots. Okay, we're going to pull our roots from the parentheses. So our roots are going to come from those two parentheses. So the roots must be negative 1, 0 from the first parenthesis and 3, 0. So that is helpful. I can start by putting those on the graph. Let's find our AOS, our axis of symmetry, so we can figure out where that's at. So negative 1 plus 3. Remember, I'm averaging my two roots. Equals 2 over 2. Ooh, 1 is the same as the last example. It's 1. And now I want my vertex. My vertex has to fall on my axis of symmetry. So the x value is 1. I need to find y. So I get y is equal to negative 2. 1 plus 1 and 1 minus 3. Let's simplify. I have negative 2 times negative 2. So if I reason through that, negative 2 times 2 is negative 4, times another negative 2 is 8. My point should be somewhere around there. And then I almost have a complete picture here. I would say if I was to make a table, if I plugged in 0 for x, that would be helpful. So I get y is equal to negative 2, 0 plus 1 times 0 minus 3. Gives me negative 2 times 1 times negative 3. Negative 2 times 1 is negative 2 times negative 3 is 6. So put that on my graph. Reflect it. And then I would draw my parabola through my points. Thanks for watching.